Hello, everyone. Welcome to um, the lab for today. And today, in our lab session, we are going to be looking at Project 5, and it's about light and darkness detectors. So, we're going to make attempt to demonstrate on how you can build simple um, circuits that has the ability to detect light, and upon detecting light or darkness, a, a particular component is able to energize or activate the performance of that circuit. So that's what we're going to be looking at in the lab today, and that's going to be very interesting. Okay, so we are going to be looking at three different schematics. Actually, the same schematic, we try to modify it into different functions. Okay, so the first we're going to be looking at is a simple light detector. Okay, so this schematic has the ability to um, energize the circuits upon um, detecting lights. So when the circuit is exposed to enough light intensity, the circuit becomes enabled, activated. And then the second part, we're going to try to include an alarm to the circuit and then see what happens in light condition, how the circuits will be energized by light, and at the same time able to sound an alarm. And then the last part of the lab is going to be looking at trying to modify the circuit to start functioning as a darkness detector. So for these three cases, we will be talking about the applications, the usefulness. Okay, so if you go to your lab manual and then look at it, you'll see that we are going to be starting with the first task, which has to do with building a simple light detector. So we get the components. So the components for today will include a 9 volts battery, DC source, and then 1 kilo ohm resistor. So you'll be looking at for brown, black, red, basically. Of course, there is the fourth color, the gold, which is mainly for tolerance. And then we'll also be needing two 10 kilo ohm resistors. So you'll be looking at for brown, black, orange. We're going to be needing one LED. So we may use green, but you have red and green in your kits. Then we're going to we'll be needing one NPN transistor, of course the one we have been using, BC547. And today we introduce a new component called phototransistor. Okay, so that is going to be also one of the components, in fact the main components that will be detecting lights for us in our designs. So the phototransistor, it's can be compared, it's just like a normal transistor. It has two terminals. Okay, but actually in the recent it has three terminals, but you won't see the terminal of the base. So it's, by appearance it looks like a normal LED, but it's white in color. So it has two terminals which are the collector and the emitter. And just like the way the LED is, it has one terminal longer than the other. The longer terminal is the emitter in this case, the shorter one is collector. Now the base is actually the photo element, the body of the photo transistor, the white part of it. It's the base because that's where it senses uh, the light. If you look at it very well, you see it's a transparent white glass or white or plastic, whatever, but transparent material. You could see the two terminals inside. So that is a light sensor, okay, and that represents the base in this case. So we're going to pick these components, and of course at a point we're going to be needing a buzzer that will help us sound an alarm. So let's get our components ready now. Right, so that's the breadboard, and then you will be needing the buzzer at some point. Okay, the battery cap, and then that's my 9 volts battery to power the circuit. And this is my transistor BC547. So I need one of that. So just one. So I just took one of it, okay. And then I'm going to need 1 kilo ohms resistor. So I'm going to pick that from my kit. So you're looking at for black, brown, black, and red. So that's it. Brown, black, and red. Okay. I'm going to be needing two 10 kilo ohms resistor. So for the 10 kilo ohms, you will be looking at for brown, black, and orange. So I think that's it here. Brown, black, and orange. So you need to be careful with the colors because orange is almost close to red, so you don't get confused. So I will need 2 pieces of that resistor. Okay. Then I'm also going to be needing the photo transistor. So you look at for the photo transistor, okay. It's just like a common LED, like I said before. So that's the photo transistor. You can see it has 2 terminals. If you look at it very well, one terminal is longer than the other one. So so that's it. Talk more about it while we go use it. And then I need 1 LED. So I'm going to be using green this time around, and I will be needing some jumper wire. Now this is also a jumper wire, though this is not insulated, so you can use it as well, but just to avoid components from touching each other to cause short circuit in your design, especially if you want to use them closely, you may decide to use the insulated type. You all have all that in your kits, so I may be needing some of these just to extend and join my components in the design. So let's say I need 3 of that, okay. Right, so I think basically that's all the components we'll be needing for project 5 to build the various circuits. So we will begin to build. So let's start. So I pick my transistor. As usual, I like to start with my transistor for no special reason. Like I told you before, it's a very dynamic process, so you can start with anyone, you can start from anywhere. So I don't have any reason for starting with my transistor, but it's very dynamic. You could start from anywhere you want. Okay, so don't forget the terminals of the transistor. You have base, emitter, you have collector, but just the way it is arranged, the first from the left here is your collector, and then the middle terminal is the base, and of course the third terminal is the emitter. So that's it. And like I used to do, I need to arrange my breadboard to know where my supply line will be coming from and where my ground will be coming from. So I've maintained that I want to use the first line as my supply line. So that's going to be my red terminal from the battery. And then the second line is going to be my ground. So that's going to be my black terminal from the battery. Okay. So the this is the emitter and it's grounded. So I'm going to do that first. So I'm going to put that to the ground here. So my emitter is grounded. So because what I'm building now is the light detector, that's the first task. So I'm going to connect my LED. Okay. So my LED has a 1 kilo ohm resistor connected in series with it. So you'll be looking at for brown, black, red. The 1 kilo ohm is to limit the current flowing through the LED, so it doesn't get damaged by excess currents. Okay, so we use 1 kilo ohm to protect the LED from getting damaged by the flow of excess current. Okay, so that comes from the supply, so you can put it anywhere. So that's the resistor connected from the supply to anywhere in the circuit. And then the LED is, I'm going to be using green. So you can see the long leg is connected to the resistor, the short leg is connected to the collector of the NPN transistor. So the long leg is the positive leg and the short one is the negative. So the current comes through the long leg and then it goes out through the short leg. So you need to keep to that convention when you are trying to connect it in the circuit. So I'm going to do that just now. So my LED, so that's my LED connected. Okay, so the next thing is to connect the two resistors R1 and R2, 10 kilo ohm resistors, and then the photo transistor. So the first one is R1. R1 is also connected to the power line from the battery, and then it's connected to the collector of the photo transistor. Now the reason why we have R1 connected in series with the phototransistor is also to limit the current flowing through the phototransistor, because these components have limits of current that flows through them. So if you expose them to excessive current, that could damage those components like the LED and the phototransistor. So the phototransistor also have a current limiting resistor R1. So I'm going to put that here. It's also connected in the power line. So my power is the first line here, so I could just put it here, and then I'll connect my phototransistor. So it is the 10 kilo ohm resistor that limits the current that flows through the phototransistor is actually connected to the collector of the phototransistor, and the collector is a short leg. You can see there are two legs here. You can see the long and then the short. So the long is the emitter, the short leg, the short terminal is the collector. So that's the phototransistor. If you look at it very well, you can see it's transparent, and then you can see that's the photosensitive element. So that's what you're seeing, and that is the base part of this transistor. So like I said, it has two legs, and then the base is the photosensitive part of it. So let's do the connection now. It's connected in series with R1, and that's the 10 kilo ohm. So I can just put it here. So that's my phototransistor, and the collector is connected to the base. So I will be needing a jumper. That's my jumper wire, and that's connecting here to the base. Okay, and just try to keep it low so you can see. So finally I need to connect R2, which is also 10 kilo ohms. So you're going to be looking out for the same colors, brown, black, and orange. So this is connected from the base to the ground. I think the base is closer to the ground, just behind the NPN transistor. So the base is the middle terminal. So I could just do that. It's very close. So and then that goes to the ground. The ground is the second line here. So I think I've connected everything for my light sensitive circuits. So this is my light detector. So next, I just need to power it. Okay. So that's my battery cap, and I need to keep to the plan I have, the arrangement on the breadboard, that the first line is my supply post. This is the positive line. The second line is the ground. So this is the way I've arranged and planned how my circuit should be connected. Okay, so we'll need to now test the circuit. Now, because it's a light detector and I have light here, when once I power it, it should come up. Okay, because it's detecting light, so you can see that it comes up when I put the battery. Okay, so you can control this by covering the phototransistor, because this is what that is sensing the light. Okay, and that part is the sensor. Okay, so it's going to be like a switch. So if I try to shade it from light, it switches off the LED, and if I expose it to light, it comes on. Okay, so that way you can control the switch. So but on a better way, I've got the cap of my pen, I could use that to control it as well. So if I cover this, I should have the same effect. And if I take it up, I should have the same effect. Well, it has a hole, so you may decide to cover that hole if you have something like a black sellotape, so you don't have any light getting into it. Okay, so I can decide to do that. To avoid my battery from running down, I can just switch off the circuit. I can decide to close up the hole right on at the top of my pen cap, so I can take off the hole. I've covered the hole on the pen cap, so no light can go into it. So with this, you can just control your photo transistor from receiving light, and as well as a receiving light, so you can shade it and as well as expose it to light. So that way and that way. So this is a simple light detector circuit. Now the second part is just to make it sound an alarm. So that's the second task. So if you look at the second circuit in your manual, it's just a modification of this. Include a buzzer, just includes a buzzer. So you have a buzzer in your electronic kits. So if you check your kits, you're going to see a buzzer, and the buzzer is polarized. You can see it has two terminals, and they are colored. So one terminal is red and the other is black. That means it's polarized. So you need to keep to that convention when you are trying to connect it into the circuit. So from the circuit diagram, all we're doing is just to connect the buzzer, the supply line. The red line of the buzzer goes to my supply line, which is the red, and then the black, which is the negative, is connected to the collector of the NPN transistor. Okay, so let's do that. So the red goes to my supply lines, and then the black goes to the transistor collector terminal. Yeah, so that's my buzzer connected. So let's see what happens. So all we want the circuit to do this time around, like we captioned it, is a light detector with alarm. So we expect that when the phototransistor is exposed to light, it should switch on the LED and at the same time sound the alarm and alarm. So the buzzer has the ability to sound an alarm when it is being powered. Okay, so let's see what happens. So you can see that's the buzzer for you. That's the sound of the buzzer. Okay. So that's the second part of our demonstration. So the last part is modifying the light detector to become a darkness detector. Okay, so that is the last task. So if you're looking at that last circuit in your task 3, we're trying to build a simple darkness detector. Now before we go into that, we need to look at what could be the application of these kind of circuits. We have just looked at a light detector, and then we're at a light detector with alarm. What could we use these circuits for? What are some of the applications of these building this kind of circuits we have here? Now for the light detector, you could use it as an automatic switching, of appliances upon detecting light in a security system. So if you have a security system, you could have this integrated into the security system just to monitor the presence of light. So when once light is detected, it quickly trigger some appliances, try to switch off an appliance that will function based on the fact that light is being detected. So you can use it in a situation like that. And then, of course, it also could be used with the alarm to monitor a system that is sensitive to light intensity. So a system that has a particular level of light and operates and functions under a particular light intensity. And that whenever the light intensity gets above the normal, then the light detector quickly triggers an alarm in that circuit. Okay, so you could use it to monitor light intensity in some special systems. Then this one is very funny. At home in your wardrobe or in your cupboards, some of you that have those special wardrobes, when you open the door of the wardrobe, you just see light come up. You just see a light come on, and then everywhere becomes littered in the wardrobe, and you could just pick what you want to pick. And when you close the door of the wardrobe, the light goes off. You don't know the underlying mechanism. So it's using a light detector. And because when you open the wardrobe, some rays of light gets into the wardrobe, and then those that fall on the sensor quickly energizes the circuit, and that brings up the light, switches on the light automatically. And when the light switches on, the intensity of light will add more light intensity on the photo transistor, and that process continues, and so the light stays. Okay, and then it stops when you close the wardrobe. At that point, the photo transistor, it's now in a dark condition, so it will automatically switch off the light in the wardrobe or in the cupboards. Okay, so these are some of the applications of our light detector, with or without alarm. So we now go straight to look at building a simple darkness detector. So we try to modify the circuit. Okay, I would put a folder that now. So what we're going to be doing is we're going to be taking off so to modify, you just take off resistor R2. So that's not going to be there anymore. Okay, and in place of R2, you're going to move the light detector to that position. Okay, then you now have R1 is now connected to the base and the supply. So that's what we've done. That's R1 is now connected to the base, and then the supply, my battery, the supply line. So the base and the positive of the battery. So that's R1 10 kilo ohm. Then you're going to be connecting the photo transistor will now be connected to the base of the NPN transistor, and then to ground. So the emitter goes to ground, so I can do that. That's the emitter. Okay, so it goes to emitter, and then this goes to the base. So I'm going to do that. So this is a simple modification. The LED is not affected because we're not modifying that part of this circuits. Okay, so normally as a darkness detector, the light is not expected to come up because at this point it's designed to detect only darkness. So let's see. If the light is coming up, it means the phototransistor it's not receiving enough light. So at that point, you make sure it receives enough light. Okay. So the light is not meant to come up because it has to sense the light. So let's see. Trying to adjust my light so it could receive enough light. So that's my circuit here. You can see upon receiving enough light, if you expose that to enough light, you can see that in the presence of light, it's switched off. The circuit is off. Okay, so we can still use this. This is our darkness. Okay, and then that can control the circuit for us. So upon sensing darkness, like a shadow, the light comes on. If I take that off, the light goes off. So that's a darkness detector. The circuit is only energized in the presence of darkness. I could just do this as well, like a shadow. So it's a shadow detector or darkness detector. Okay. So some applications of these circuits, it's very common. Number one, we could use this circuit to light up street lights. You know, in your area where you stay, you look at the street lights, you don't have anyone going around to switch them on manually when it's getting dark. You could see all the street lights coming up almost at the same time. Okay, this is just a simple demonstration. Those street lights have sophisticated electrical circuits that perform that function. So when it's getting dark, you see all the street lights being activated and they come on by themselves. And then of course at home, some of you that have these nice fancy security lights, you also observe the same thing. In the night, they come up by themselves. When it's getting dark, you don't have to go and switch them on. Some of them don't even have switches right within the house. They come on by themselves. And then in the morning, they go off by themselves. So upon sensing darkness, your street lights come on. And then while the day breaks, as it senses light, it goes off. You could also include an alarm to it, the buzzer, just the way we did in the first case, and then it will sound an alarm. So the buzzer is connected to the positive supply line, and then the second terminal goes to where the transistor collector terminal is. Okay, so just connected there. So that's the buzzer for you. So once again, you can see that. So upon detecting darkness, it sounds an alarm. You know, that's the buzzer sounding. And then of course, if you take it off, it goes. So this is all we are going to be doing in this lab, and I hope you find time to get yourself busy building these interesting circuits. Okay, you can use a light detect a darkness detector in home automation systems, like I just explained to you, and also with the alarm, it could be used in some security systems to sound an alarm when you have an intruder, like we did an intruder alarm. So if you have somebody going by your house, just the shadow, it detects the shadow of someone and quickly raises sounds an alarm to alert people at home that somebody is just going behind your house, and then your darkness detector is able to see the shadow of whatever is by, and then it raises an alarm. That's it. Okay. All right. So that's all we have for the week. And so just find time to enjoy yourself with these circuits, occupy yourself with them, and of course, have fun. Okay. Thank you.